ahead of Republican presidential nominee Donald Trump are wrong. That's according to an artificial intelligence system that's managed to predict the last 3 general elections correctly. The AI called mod8all was developed by Right. It takes into account information from Google,
Hold on.
Twitter, and YouTube in the US, then analyzes that predictions. Data such as engagement with tweets or Facebook Live videos have been tracked. The result is that Trump has overtaken the engagement numbers of Barack Obama's peak in 2008, the year he came into power, by 25%. Rai said that the candidate in each election who has leading engagement data ends up winning the elections. Most polls, however, put Clinton in the lead, and if this AI system is correct, it would be a big surprise. The model is not foolproof, however. At the moment, it's unable to understand sentiment, so even if Trump has more engagement, it might not be positive. Either way, the AI software thinks the race is closer than it seems.
So what is the point here? Not telling you anything about the political issue, but AI, okay? AI, the Google AI systems are predicted, forecasted accurately than any other human related the poll systems. You know that, right? So what did they use?
Data mining?
Yeah, it is data mining. And what is the data to be mined?
Open change?
Which one?
How to root this off America?
Rather, how do we piss off half of America?
I hate that. That's not what I want to bring here.
Right.
Why should I bring this? Look at that. AI system finds AI system. Okay, that is the issue that I want to discuss with you. That is the whole point that we are doing in this class. Data mining technique has been used in many applications, particularly at this time for presidential election. Almost all media failed forecast, but artificial intelligence. How come artificial intelligence can do the forecast a lot more accurately than human? Because AI, which is computer programs, right? Computer program can use massive data that human cannot imagine, human cannot handle at all for the given period of time, but computer can do. The data, type of data that, what is the system? What is the name of the system? Anybody heard of that?
Which system?
What's the name of the system that forecast accurately this time?
The White House.
There's a called mod8all. mod8all, developed by one of the Indian guy, whose name is Sanjay Gupta. No.
Dr. Sanjay Gupta.
Sanjay is the same first name. Sanjay Rai. R-A-I. Sanjay Rai. Right. So he developed a simple data mining program, and he had a proven record. Accurately forecast last 3 the presidents. The first term of Obama and second term, and also at this time. Okay.
I mean, so did Nate Silver, except for this one.
Well, that system accurately forecasted all 3. The data that system uses was all kinds of social media.
There's a guy named Alan Lichtman who made this thing called the Keys to the White House, and he's been using it. He published it back in 1996.
1996.
But he's
Okay.
been using it every year to predict, or sorry, every election year
Uh-huh.
to predict who was going to get the nomination. In October, he claimed that Trump was going to win the election.
Oh, that
Because he said
is it human forecaster or is it a
he was
program?
forecaster, but he had made a system. He's made a system of questions, and if the presidential candidate meets the answers to those questions, they're more than likely to get the
Okay.
presidential vote.
So that is also the software-driven
right,
forecast.
but no, it's not software.
It's a human.
It's human, but it's
Okay.
something you can put into a software program.
So software compute somehow.
Because he
Is
says
there
that
some
He
complexity?
doesn't take information from polls. He's just taking information.
I'm not sure. We're not talking about that type of program. So we're talking about data mining.
I know
Okay.
it's a physical data mining. It's not just.
Are we saying that the computers all want to make America great again? I'm just kidding. I'm sorry. I'm trying to.
Good question. Good question.
I'm sad.
Why don't? Yeah. Okay. So there's a project that William will do. Okay. So we all expect one outcome from you. Okay. The social media. So, tell me about the social media. What type of social media that you are using, for example? Everyone uses Facebook. And
Facebook,
Twitter,
Snapchat,
Instagram, Snapchat,
Reddit.
Reddit.
You
Yeah, right.
Surprised how many
Pretty much all of those.
on Snapchat.
Right.
IRC even.
Pretty much all of those that miner will look at and search the keyword of those two candidates. Okay, Donald Trump or Hillary Clinton, and find out how many, for example, the post contains the word names of those two candidates. So more names, I mean, more frequently, any particular candidate's name appears on the social media, then that data miner give higher credits. So collect all such data and then finally made a decision.
Professor, I mean, you said they search, maybe Donald Trump's name on the net, but how do you know it's positive or negative?
Doesn't matter.
Doesn't matter?
Right, yeah, doesn't matter. Positive or negative. Because they think, people's opinion may change, right, as they discuss. So if particularly by that program, right, there's too much. If they think, by reading the whole paragraph, then another decision maker needs to be involved. Then there is so much gray areas. Is this really negative? Is this really is it 50% negative or 20% positive and things like that, right? But that simple data miner, but it searches through daily basis for 2 or 3 years during that campaign and find out whose name appears more actively. So the annotation after they forecast was that the guy elected name appeared a lot more than loser. Okay. Well, that is the benefit of data mining. All right. So today, the homework assignments. I know many of you probably disappointed at not submitting or not completing homework assignments on time, don't worry about it. Okay? What I mean by that is, if you have done all the requirements that I assigned, then you are the top. You can be proud of yourself. You can take it to your interview. Trust me. Okay, I can say trust me. Okay? Trust me.
I'm right. Believe me.
I mean, truly speaking. For example, for association rule mining, in that homework assignments, I ask you to do association rule mining manually, using all. There are a couple of the all exercises are possible, and using Python. If you do that all, and if you have some idea of the clear comparison, then you can take it to interview and then explain using your work, and then I'm sure the interviewer will be impressed. So initially, when I designed this class, in this semester, particularly this semester, I tried to make every single homework assignment will be a good the project that you can use for your interviews. But I changed my mind. From this time, I'm not going to give you that big volume of the homework assignments, but I'll give you lesson a little bit, okay? Like many other course. So don't worry about. I'm sorry?
I stayed up all night for the Simpsons one.
That's good. So, for example, today there's no hands-on. Just sit back and listen, okay? Okay, what we will do today is to, for classification, we have only 2 topics remains. There are a lot of topics and techniques that I can deliver to you through this course, but now I want to we'll stick to simple topic a little longer, so that you at least you understand what it means, rather than I go so fast, you guys trying to follow me, a lot of hectics, losing some of the ideas, topics that discovered or discussed already, which is not good. So I'm going to minimize the work. Okay, classification. There are, among many classification algorithms, we're going to deal with the 2 simple algorithms, simple techniques: decision tree and k nearest neighbor classifications. Okay, decision tree. I want you to understand what decision tree means, and what is usage of decision tree, and how to construct a decision tree. At the end of this slide, I post there, for those who do not know what to do for your group project, then
No idea what
is there anyone who can invite Stephanie into your group? You're already fine. That's good, right? Yeah. I found out orphanage, Stephanie, orphanage from this class. Yeah. Raise hand if you are not involved in any team, yet at all. Yeah, you can. Yeah, you need to find out and join together. Right. Thing is this: by collaboration, I want to make a little bigger and robust, and also intelligent work, so that the work that you could do for this class is not just only for this class. You can take it to your interviews. Okay? You don't need to appreciate me. But I appreciate you if you successfully find a good position eventually. Okay? Trust me. And also, if you need help, come and see me, okay? As a group. You all together come and see me, then, yeah. I do not want to talk to one member, then there's no collaboration.
Yeah, but I mean, like for people who have full-time jobs and can't quite get here at the same time as everyone else, or if someone works nights, or
Well, there's always, no sacrifice, no,
snow is left behind.
that happens always, right? No investment, there's no output, no gains.
Yeah, really.
Thing is this, decision tree is simple but very, very powerful. But given the same data sets, there may be multiple ways of constructing decision trees. So you may be able to see which one's the best decision tree. Can you make it by hand? If you can, of course, in this slide I give you some measurement, which one's better, the decision tree. And then you can implement it. So your program, your software can automatically generate the best optimal, best decision tree. Then it can be used. This kind of a decision tree is very, very powerful to install. For example, intrusion detection, intrusion prevention, all kinds of cyber security defense. Okay, trust me. Okay, so here's an example: network traffic data. We all know that packets are available over the network, not necessarily the Ethernet, but Wi-Fi or your cell phone or any other applications. Okay, so each and then you can collect data. So you have a good size of data. As you can see, there are multiple, the origin of the packets piled up on your table, on your records. So you may have n packets. So some of the packets, there are maybe some suspicious tokens. Okay, so how can you, what do you learn from there? Some set of suspicious tokens. First of all, you do not know which ones are suspicious tokens, right? So data mining, one type of data mining is to train your system so that you will be a supervisor. Trainer will be a supervisor. Your program will be, therefore, supervised learning, which means you teach your program by saying that, hey, this type of packet is malicious. This type of packet is a good packet. This type of packet is something. So you can classify given set of packets. And then you can run your software, so your software, I mean the data miner eventually learn some lots of patterns. So next time at the real testing phase or a real application where you deploy your data miner, then you can collect and automatically classify the given packets properly, so that you have multiple bins of the packets. So there's a big bin of packets, they are all good packets. There are another small bins, oh, this is malicious, but by the way, this is try to gain some type of data breaches or some others, okay? Those are all possible. They're all supervised learning. At the same time, we can think of unsupervised learning. There is no teacher. So simply the miner, data miner itself, to learn. Therefore, given data sets can be properly clustered because there is no teacher. Initially, that data miner do not know how many classes properly classified, and also the number of classes is depend on the size of data. For example, given set of data, you have, let me tell you here. Okay. Given set of data, say delta, from delta you have class 1, class 2, and class 3. Next time you have more data, delta plus D, which is bigger data than the other, right? Because of more data, you may have class C1 and C4. And next time you may have more data, so delta and D plus D2. Therefore, your miner may generate class C1, class C2, and class C3, and class C4. Okay? It's not really monotonically increased. It's not linearly increased or decreased. So purely depends on the characteristics of data. We can generate different sets of classes. That is unsupervised learning. Supervised learning is that given set of class, and then your miner will determine which class on objects belong to. Okay? Simple, right? So supervised learning assumes that there is a set of classes given. And then, based upon the set of classes, your minor learn some. So, hey, for example, we have 3 sets of student body. Good students, normal students, bad students. Okay? So, looking at the good students, then there are students who has a lot of features. Name, GPA, phone number, date of birth, which is age, or sex, male, female, or types of training, whether veterans or not, and all kinds of features are given. So looking at those features, your rule minor say, hey, veterans, they are good students. For example, okay? Don't blame me. Trust me. And for example, GPA is so low, then bad example. Not really, right? It's not necessarily. But let's say that type of patterns may be discovered. Okay? So what is given? Classes are given. Hey, this is good students, this is bad students, this is normal students. But unsupervised learning, there is no such a priori knowledge given. Simply sets of data, your minor will look at and find out, we have 1 class. Hey, we have 3 classes. We have 2 classes. Things like that. All right. Application of classifying cyber data. We can classify the packets. So functionally related packets header data. We can find out source and destination, port numbers and timestamps, control bits, and by looking at those data, you may be able to classify. How many of you know Wireshark? How many of you can collect such data quickly and real time from Wireshark? Yeah, okay, Evans can do, right?
Yeah.
So you can collect the data and then try to classify. Those who knows how to do that in Python, then definitely it's a lot easier, right? Another thing is classify the payload tokens. So discover new subtypes of offensive or defensive samples, looking at the payload. Okay, search through the payload of real-time incoming and outgoing packets, and collect the data. There is a cyber security related data. And then you can classify manually. Hey, this is good data. This is a good packet. This is a bad packet. This is malicious. This is attack packets. This is whatever control packets. This is, you classify that. Okay. After that, you can make a decision tree. Okay. Let me skip this a little bit. So, for example, So you have a number of packets. This is a simple example, right? This is not, these are not the data that we are interested in, but this data is, for example, customer information, who wants to buy computer. So that by looking at that, well, the first 4 columns, then we can get them from customer database, right? So age less than 30, and income high, whether the client is a student or not, credit rating, we all know that, right, at the stores. And then either the real physical store or from the internet shopping, you can see that who eventually purchased or not. So you have one more column, say buys computer, so yes or no. So those are label. This is a label, right? Let's say this is a class label. Class. So class label is attached to each record. This is a training data set. So by this training data set can be used to construct a decision tree. So this is a decision tree. Without any detailed explanation, I think you can quickly understand what this decision tree implies, right? William, can you explain this?
Me?
Don't hide.
Too late for that.
Yeah.
You hadn't moved in.
Sorry.
Yeah.
This is a tree, right? You all know this is a tree structure. If you do not know tree structure, then this is the time that you can see, oh, that is a tree structure. Okay? Tree is one of well-known and high-performing data structures. So it starts from the root. This is a root. This node is called the root. Okay. Actually, this is a tree upside down. This is a root, and we have trunk. And trunk has branches and things like that. Okay? So this is a tree upside down. So explain starting from the root, William.
Explain the tree from the root.
Mm-hmm.
Okay. Challenge. Now, the root is the age. Basically, now you broke into the middle branches, or under 30, 30 to 40, or over 40. Okay. And those get subsets, more branches. It's basically if the root's coming from the trunk, branches, it goes to the twigs, it goes to the leaves. It just keeps going out.
So I'm seeing.
Oh, thank you, Dave.
Yeah. I was going to help you do it.
Yeah.
If they're a student, no. And they're under 30, then they probably have bad credit. If they're a student, yes. And they're under 30, they probably have good credit.
Oh, great. Thank you so much.
40,
You know what David said was that he said if age is less than 30, then next question is that customer is a student? See here, at this level.
Oh yeah, because I'm exhausted.
At this level, hey, listen. At this level, if if customer's age is between 31 and 40, then there's no additional questions needs to be asked, and simply we can make a conclusion. This guy will purchase. It says yes. Yes comes from here, the label, class label. See here, class label? Some over here, right? By looking at this table, we can say, oh, age in this range, definitely buy. What happens if this decision is true based upon that the real customer table? Then salesperson can spend the valuable time with the customers, right? What I mean by that, if the customer is in this age range, then definitely I need to contact that person and spend my time, and because that customer definitely will buy. Okay, that is a motivating customer. But on the other hand, if some customer say age is over 40, like me, and then credit rating is excellent, bad customer, he's not going to buy. It doesn't represent me, but for example, okay, age over 40, and the credit rating is excellent, then that type of person will not buy. So I don't need to approach the customers like this case, right? So by looking at this, yes, and yes, and yes, we can quickly make a decision whether we want to spend more time with that customer, or simply say, hey, have a good day. If we have that type of decision tree, then we can apply that to traffic control also, right? By looking at the traffic, if that is origin from, let's say, the top, this is saying origin, IP address starts from 172.92. Then, yes or no, right? Greater than number or less than number, or yes. Depending upon that, if it is yes, then you can say some others, right? This guy wants to do, for example, ping command, then the access or issuing such a command ping is very, very malicious. So this guy wants to attack our systems. So that you can simply, quick decision here. Hey, alert, this guy, this packet is so bad. Something like that. This type of decision tree is so powerful. Powerful means if you want to make this in program, well, of course you eventually you can make this in program, right? But by looking at this decision tree in the picture, it is simple. But if you want to make that in if then else statements, that itself will be long list of if then else statements. If you try to, right? For example, age. If age is less than 30, then ask students. If true, then yes. If no, no. And come back here, the previous if statements, and in this range, then we can say yes, and come back to the previous if then else statements. If the age is greater than 40, then ask credit rating. If it is excellent, then forget about that customer. If credit rating is fair, then yes. It's a long list of if then else statements, right? So this is a good tool that you can see and interpret the decision tree. Of course, if you have a decision tree, then you can simply convert that decision tree to the language that you are using. Python, whatever the language, okay? Now the question is, how can we construct decision tree? Very simple, right? Take one column and find out values. How many values here? Only 3 values. This. Right? Only 3 values. So you split those 3 values. Yes or no? And take another. And another. And another. And by having this, by considering each columns, and finally at the leaf node here, see all the leaf node. This is a leaf node. This is a leaf node. This is a leaf node. This is leaf node. And also this is leaf node. Leaf node means the node which do not have child nodes. Then there is a leaf node. Okay. Leaf node is the label. See here we have a class label. This is a class label. That label comes in that leaf node. Now I want you to try using some other attributes, starting from some other attribute. See here, this decision tree started with AG, right? Occasionally AG comes in the first column. Should we consider the first column as a root? No. Will there be a different performance if we use the different attribute for the root node? Of course, right? So I want you to try, for example, I want to make 3 more groups. So AG we have there. So 3 groups. These 3 guys, starting with the income column as the root, and then 3 of you start with the student as the root, and the rest back there, the credit rating. So that you need to cover. This decision tree needs to cover all the data in the given training data sets. Alright? Try to do that. The reason I'm asking you to do that is you need to get some motivation, so that next slide will explain some. Do it now. I need to find out where is it.
So like, my brain is broken.
Yeah, but we're gonna start off.
No, try it. Yeah.
You're gonna start. You start with it. And then down there, what it will be. So, if I know what we're doing, this is what we're okay, so whatever. And go down. The final of the day.
What did you see?
On top of the we just
Does he have that post?
Maybe we can put it in group then. Both.
Which one do you got? Income? How much are you income? What's this extension I was
Okay. And we're sure it's me.
I'm not. You just,
If
if you just sit here, walking up, keep making circles, you already know why I'm hoping for you sound
I
further.
thought I was like, how do you get like he's a pound?
It's called circular logic. It works at that.
I know. That's the scary part.
Just tell everyone it's all rigged.
How's someone dialing me? Okay, well.
But it would be
How going?
Where are you?
What?
Yes, no. No, real age.
Yeah, I think they're age right now. Just like you're starting from the middle, so. You just do like students age income and then ratio. It depends on the student that turn on.
If that works.
Oh, so this will be. So we got students yes, students no.
So if the student is known, so you should see a bird that the student is known and maybe on soccer, usually students are that's the beginning. So if it's a known, then it's very high or
Why are you doing a graph? Hold on. Why are you Let's grab paper.
It's busy.
Video.
You're going to use
the medium stuff.
I actually have time.
Okay. If your visual work is better than
So maybe
Like what we do is yes, no. Then age will do what he did after each.
yeah.
Well, avoid.
Well,
So
the
what
age
is
is
the
still
Brian
pretty
Williams
flexible.
said,
They're pretty
and
flexible.
So it's still wrong.
So
you heard it too.
No, I was.
So, oh. Very, very
What? No, really income.
I was watching.
Income timing, low, and then from there, I guess we'll
I was watching
delete
CNN. What a rule.
I guess we're going straight down to age.
My brain is shut off. You're up until 2? It's, yeah.
Yeah, but they didn't call
Once
it.
Associated Press called Pennsylvania, I was like,
They didn't call it.
I went to sleep because I was like, you know what? I want to have at least one last good night before my computer starts talking to me before I go to sleep and being like, you need to complete this task before we let you sleep.
yeah. We're living in like 1984 now.
It did.
Oh, we're literally living in 1984. It's basically bring it all
Over or equal to 30. Oh, it's under or equal to, right? Yeah.
I can't read that either.
Listen,
It's like it
it's
looks like
magic. And wait, because I'm going to make it even smaller.
Thank you, Evan, for trying.
It's not quite as well.
Oh, dude.
I told you, guys, it's smaller.
It was my bad. Which is we skipped to the
It's no, then the H, we put that, and then it's for the
Polarized.
they both have like 3 tiers.
Oh, yeah.
We're doing things for stuff that does that one other thing.
Yeah, well, we could
See?
find computer.
Perfect example. No way.
See why.
my computer will be the lot of work.
Anyway.
So
Okay, cool.
It's for the start with the food, yeah. Well, we can see it.
Exactly. So so only one thing that we do.
Every is going to have something different. Most of the like students just know any kind of stuff. Yes, it's slow. It's hard to break it up.
Yeah, well, it's at 67% Zoom, so when I actually move these to where it's supposed to be, we will be able to see it much better.
Nothing on the dirty.
Well, under 30, that would be hard.
So we can put.
Okay.
It's hard to break it up.
So I've got
In
8
order. That's like a good order.
Exactly. That's what makes the most sense.
From income, we can get student credit. I hate this game.
I made this good idea.
We need to use income for you. Income?
That's easy.
Yeah,
So, Kanye 2020?
No.
yes!
At this rate, probably.
Yeah.
Who knows?
So after age, is for each one, it also puts income is higher than the lower.
So you can create the yes, sure. So whatever you like or intro or something else.
So would we replace age with income, or would we put income up here and then the different age groups?
Yeah, we put income as a just to change the age to
That's all. Erase that. So we can assume everything from 31 to 40. Yeah, that's fine. How they spread that out. So we can only do like maybe 30 to 40. Because everybody in 31 to 40 already specific attention person. But well, anyone 31 to 40 is just anyway. Yes.
It would be directly yes.
Yes. And then the others would be
Again, it's what we want.
we would have to rank that clause.
And that's all the photos. Which one? You gotta fix the right?
Yes, yeah.
I don't know what it is. Look at you, huh? Some of them are not really decent. Not a lot.
That's where it's perfect. That's the only top of their time. How it's perfect.
Yes, I can that
Dude, I wish we don't sit back and listen, because that shit's fucking annoying. I don't learn that way. Actually, like this is bullshit. But like, as far as sitting here and learning how to use fucking Aurori, whatever the fuck that was, that would be helpful. Instead of just saying, hey guys, I'm gonna show you something in 2 minutes, and it's homework.
you were focused.
Go crazy.
I don't know how more.
Dude, how the fuck do you don't understand seriously? I swear to God.
Wow. You know, it's joking. It's not getting more photos in there.
I know. Yeah, you have another space here for no reason.
Because remember we were joking around, I'm just gonna crop.
I know, that's what I'm saying. Like,
Whoops.
what photo?
Right, so, okay, but that pushing about the war more.
Or it's the New Yorker. It said, Queen offers to restore British rule over the United States.
Oh, okay, 2.8. Mm-hmm. I think it's my child photo.
I don't know. Actually, no. Wait.
I wasn't ready to listen. I wasn't ready to listen at all. He saw my camera. I said, take photos. I said, oh, yeah. Yeah. And, you know, I would have had like a mic and everything to maybe do the videos and like you know how loud the
of course,
that's not amazing. So you see
Yeah, I'm starting to care less and less being that I can't fucking open this goddamn thing.
So you have one picture of it.
we gently get my camera. I'll go to the next one. I'll take a good portrait of me.
1.8. Yeah. I'm gonna do that.
Well, we have some good pictures. Good job.
It's hard to move.
Joe Biden really is sad.
Oh, this is good. Yeah, this is good.
This was not so.
And was that just the last weekend? No, so
I don't know.
Yeah.
Anybody has done so that we can share?
Dude, if you could share that Excel thing so I can, accurately put this into something.
Did you send it to Pablo?
Can you
Change coloration.
Can you save it
fun.
in PDF and send it to me in Blackboard so that I can post it and we can discuss together?
If you
And compare with this. Simply. So send it to me in your Blackboard.
Can you send me just that little chart right there? Can you send that to me in a Excel spreadsheet so I can change the cells that are done? Because I'm trying to do duplicates and I'm not having fun with this.
You got the smart.
I'm running out of battery.
If you're long enough, you want. 8 minutes. Yeah, no, I forgot to CBS.
That's gonna be pretty short.
This is a break.
No,
It's
no,
not
no,
a
no, no,
break.
no,
It's a
no,
break.
Yeah, yeah.
Yeah, that's a pretty sharp like from an angle. You sit you down on the bench, like you're kind of looking at it, and then you just right there. Right out like here. That'd be good black and white. We can exchange them. Right.
I said I need your break, and I moved it. Because you take up more space than you need. Oh my god, no. Okay. So we're on the mediums. Mediums.
We just because we got that against the New Zealand. You'll
All I can say is the comedy shows will be amazing for the next couple of years. Anything?
The other review for his finances in late November, That's going to be interesting.
Okay, it is.
Yeah, because
So that is in the Blackboard right now. I posted here sample data sets of your course material and slides and more. The last item is sample data sets. If you click that, oh no, if you click this, then you can see it. Just image. I don't have data. Anybody sent to me yet? Let me check.
Man, you're asking for a lot right now. I can't even change coloration, the cells are done. Russian.
Thank you for your service, Adam.
I hate my service.
You need PDF?
What file do you have?
I can share with you.
Yeah, anything that I can emulate on my
So anyone
laptop will be fine. But PDF is usually good.
Upload it?
So, email attachment within Blackboard. Okay, this is the work done by one of the students here. So, okay, good. So Ishan, would you be able to explain? Yours, this is done by you, right?
Yeah.
Yeah. Explain that compared with the given tree structures, how they are different, and tell me efficiency or inefficiency or any improvement possible. Although you submit that, you may feel you could improve if you can. So explain that.
Improve? First, in income, there are three high, middle, and low, and then I just choose one column, age of students or credit rankings, and then I just do it continue. I don't know, and I don't know how to explain.
William.
Yep.
No, William. Based upon the answer that you gave us about an hour ago, you are familiar with the tree structures. So from your tree structures, which one's better, why? Which one's better and why?
Which is the tree, compared to the professor is going to give you the grade and the student? Okay, which one would I compare to? Okay. I like yours is more in depth. Yours is just kind of there. The age, I don't forget how come. Okay, that makes sense because the excellent, we just had no. Why was it just no? We need to be a little more in depth in that one. Because people of credit usually know they can afford nice things, so why don't you try that to make them purchase it? Age, let's go with student. Student. No. This one here, though, 18 to 30, usually that's like, people are trying to market to because that's who's buying everything. Thing is, though, they don't like being marketed to. Am I being recorded? Yes. That's lovely. Thanks. So, yeah. You just should have lied to me.
Against you, right?
Yeah.
So your voice will be available over on YouTube.
Sup, Devane? Sup, Yusef? Okay. No, I gotta do a shout out to the people on comes up. I'm just looking over that.
I just have 20
Alright, I got nothing else.
No?
No other observations at this time.
No other observations?
At this time. Admin, which
When's the polls closed?
And therefore, we have David.
Yeah.
Do you have any additive statements?
Why not? Income, it looks like we have high, medium, and low, which branches out into age. If age is greater than, less than or equal to 30, I think? Or is it greater than or equal to 30? I can't
Less
think.
than or equal to 30, they don't buy the computer. If they're 31 to 40, they buy the computer. If they're medium income, if they're a student, they buy the computer. If they're not, if they're under 30, they don't buy it. If they're 31 to 40, they buy it. If they're over 40, no, they don't buy it.
If they're old.
Yeah, if they're low income, the credit rating, is fair, yes. Excellent. If they're 31 to 40, yes. Over 40, no.
Thank you so much. I understand.
Chris.
So your original question really was to compare the two trees to
Uh-huh.
us, right? And which one we think is better.
Uh-huh.
I think that his is more logical to start with income, and because this is exactly technically how you would go through in a sale, right? Typically you start with when you're opening a sale or how much money are you looking to spend today, right? Income will be indicative of that. what that person's range would be. And then you dive into the deeper questions of age, student credit rating, things of that nature that would otherwise change how a person would come to a decision in that circumstance versus just starting with age.
Okay. That makes sense also. Right. Income, well, money is important, right, in purchase. But that is that has nothing to do with the data itself, right? If we consider data by themselves or as they are, then we do not really know what that means. I mean, it's a columns are columns. There's no intelligent way of understanding what it means. Is it really related with money or unrelated, or any values biased or unbiased? All such things is external interpretation. Okay, but in general, yes, we agree with you. The thing that I ask you to compare is, for example, in this decision tree, there is a very, very efficient path. Look at this in the middle. Just by comparing age only, we can make a quick decision. What is the whole purpose of decision trees? If you can make a quick decision, the faster and accurate decision will be better, right?
But is it the right decision?
According to that training data. This is a training data. Your decision tree reflects the entire training data. Then that is good. So simply, if you have a longer path, then it takes a longer time, right? That is number one. Another thing is that income attribute, that is the attribute that I given, right? I know some other team will start with some other attributes. So we'll take a look at a little later. But after you consider income, then there is a choice that you need to make, right? Are you going to look at age, or are you going to student states before you consider age? In what way that you choose a student to consider before age, or credit rating before age? And there's all such open questions, right? By the way, do you have any answer? Why you consider student status or credit rating first, then age along this path? I mean, tell me if you have any specific reason. If you don't simply arbitrarily choose, then you say so also.
Just choose.
You just choose, right?
Yeah, but
yeah.
I think, a lot of things can make sense, so I just choose them.
So some other cases, if you use, we do not know, right? If you choose this age before students, then might have some other structures or better structure, right? Yeah. We do not know, right? Okay, team in the middle. Do you have a, let me check if I receive any. Here, probably not yet. Please send it to me.
So we couldn't get that far. We got stuck.
My brain is.
Or even, did you?
As soon as you put that one up, I close out of mine.
Yeah. We want to compare.
Compare?
Yeah.
Compare the good to the
Did you delete it or you still have
You
some?
can't save it. I just said no and just move it out.
Ah.
To Canada.
You see what I want to, right? We need to compare whole different shapes, different structures of a decision tree, and then see which ones. I want you to get motivated to see in what way that we can construct better decision tree. All right. So let's move. Because you do not have, then we can simply do, for example, okay, so let's try to go back. Okay, so decision tree usually has two phases. You need to construct a decision tree and then use it. As you do construct, there is a training data sets. So based upon training data sets, this is training data sets, and then you need to apply some classification algorithm, and there is a classifier in this decision tree. The classifier is nothing but a decision tree. Okay? And once you have a decision tree, then you can use it. Okay? You have a classifier, and if you have unseen data, then you can simply use that classifier and make decision, yes or no. Okay, that is what we want to do. This is what we practiced. So, so next issue is this. How do we know which attributes to consider first? In order to do that, we can calculate the information gain. For example, given this is the same data sets, right? Same training data sets. We can calculate the gain based upon income. If you choose income, the gain is 0.029. If you choose students, the gain is 0.151. If you choose credit rating, then gain is 0.048. This, every time when you split, you need to calculate that. Okay? For example, we have two class labels. So positive or negative. Okay. So we have a positive, which is class P, and negative, class N, which is nothing but here no or yes. Okay. So by computer yes, by computer no. What we will do is that if you want to find out the gain of age, then you need to see, oh, there are 3 values of ages, right? And for these class labels, you need to count. For example, if there is a positive, based upon this age is less than or equal to 30, then you need to count. How many of the records in the training sets having the age less than or equal to 30, therefore it falls in the class positive. There are 2 cases. So we can count, for example, this is the age less than 30 or equal to, less than 30 or equal to, less than or equal to 30. But the classification is no. So we can add this one to here, So we have 1. And then less than 30, it says no. So another one here. And another case is 31 and 31 between 31 and 40. That is yes. So we can mark here one more. And less than greater than 40, then it says yes. So we have a mark here, and another greater than 40. So that is also yes. So we add one more here, and another greater than 40. It says no. So we mark here. And 31 and 40, it says yes. So we mark here. And another less than 30, it says no. So we have here, right? So in this case, all 3 may be counted for this. Okay? So we count this. We can fill in, right? It's not really a big problem. Having this, then okay, and also you know that how many records labeled yes, how many records labeled no. So out of the total 14. So out of 14, we have 9 yes and 5 no, right? So 9 yes and 5 no. This data itself, according to the age, that is this. The information of information split 9 cases and 5 cases, right? So 9 for true and 5 for false. That is computed by log based 2 and the probabilities. So positive probabilities and negative probabilities. Actually, the whole the logarithm here is that log probability, negative probability, and log base 2 and probability for each cases. So probability of positive, probability of negative. So probability of positive, that is this first term. The probability of negative, positive is 9 over 14. That is the probabilities, right? This is the probabilities, which is P here. So negative P, log base 2, and P, this is probability, the same probability for the case of positive. Similarly, negative, which is 5 cases out of 14. So 5 over 14 and 5 over 14. We simply plug that probability into this formula. And we add them all. Then that is the information of that. So we have 0.9 that, okay? And then we can calculate. See here, the gain of age can be computed from the information of entire table, which we computed here, right? According to the class label. Minus, from there, we subtract the information of age itself. If we consider age first from that given data sets, what is the information? So this is a given information, power of information. This is the information that we consider ag. Therefore, by subtracting whatever left over, that is the gain of the ag. By splitting using ag attributes, we have this much gains. Okay, the higher gains will be used first. So ag will be used the first, then any other in this case, right? So next issue is that what is the information of ag from the given table? That is computed in this way. Okay. We need to consider each data values that is available for the attribute ag. The first case is attribute less than or equal to 30. Okay, less than or equal to 30. The ag less than or equal to 30 is divided into positive and negative cases, 2 and 3. That is this, 2 and 3. Okay? And this whole thing, 2 and 3, is 2 and 3 means those 5 records is based on total 14. So this is the probability of that transactions, that ag values. The second term is the ag in this range. There are 4 cases of positive and 0 cases of negative. So that information is that information can split into 4 and 0, right? Because this is a positive and negative. And we simply split the classes into 2 cases, positive and negative. Therefore, we have here log base 2. If we have different class numbers, like 3 classes or 4 classes, then this base should be different. Not just 2, but 3 or 4 in this logarithm. See here logarithm? We put here 2. Why this is 2? Because we simply split into 2 cases, 5 and 9 and 5. 9 means positive, or 5 means negative. Why only 2 cases? Because our class label here is only 2 cases, either no or yes. So all the values that we consider also needs to be determined by positive or negative. Okay, so the information is split into two records for positive, 3 records for negative. Information for the second value is split into 4 records and 0 records. And same thing here. The last value, which means ag is greater than 40, can be split into 3 positive cases and 2 negative cases. This I 3, 2 can be computed in the same way that we do here, right? See here, for example, I 3, 2 can be computed. Negative total is 5. 3 plus 2. So 5 is the denominator, and numerator is 3. So 3 over 5 log base 2, again 3 over 5, minus 2 over 5, which is the case here, 2 over 5, and log base 2, and also 2 over 5. We need to calculate this. negative 3 over 5 times log base 2 3 over 5 minus 2 over 5 times log base 2 2 over 5. How can you compute this? Give me a break, right? The best way that you can do is that you can visit that website. No. How can you? Okay. So if I click this simply, then it visits the website here, right? So log base 2 of, for example, 5 over 14. What is 5 over 14? Is it possible that I can do here? I'm not sure. 5 over 14. Calculate. Log base 2 over 5 over 14 is. So we need to calculate this first. So what is the number? 5 over 2 is 5 over 14. We need to calculate that. For example, 5 divided by 14 equals 0.357. So if we put here 0.357 and enter, then we have negative 1.48. Negative 1.48. Okay. So this is negative 1.48. Here it's a negative. No. Yeah, this is negative 1.48. We have here negative, whatever that number. So negative, negative. So entire, that is positive. So we have gained this, positive 0.694. So entire information amount is 0.940. And the information after we split based on age, that is 0.694. So we subtract that. So gain is 0.246. That's a computed, right? This is a simple computation. So we have this value and that. We have 4 attributes, 4 columns. So out of 4 columns, we can determine which attribute is the best attribute that we can consider, which is this, the age. So first attribute that we consider is age. Okay? So age is less than 30, then we have a table here. Age is less than 30, then we pick up this table, this records, that records, and this. So we pick up 5 records only. That is the case here. So we have a table, right? With the same columns and same class labels. But number of records is different because we split the records. Once we have this, then we need to determine again whether we want to consider students or credit rating or income. We need to recompute recompute this whole thing. And then choose best attributes. If a student is best attributes, then we next node will be the students. If income is the best at this level, then we choose the income here. That type of decision, the construction method is not really. It is straightforward, but it's not easy to calculate, right? By your manual calculator. So programming is a lot better. Doing programs, you can compute quick and compare, and then choose the best attributes for the next available node along that tree structures. Okay, that is the way that you can construct decision trees. So this is another thing that I summarized. For example, must determine the best split points for A. Okay, sort the value A in increasing order, and find out. So you can split that. You can follow that algorithm, but in reality, in real computation, this is the formula. This is the way that you can compute. The manual computation is a little bit hectic, but once you make programs, it's very straightforward and very fast. So that you may construct the optimal or the best decision tree. Okay. This is the decision tree based classification. Any question? Okay, so we will take 10-minute break. Huh? Or should we do? It's not good time, right?
I mean,
almost 8:10.
I would personally rather go continue and finish earlier, so we don't get stuck in traffic on the way out. If everyone's
How many
okay with
slices
that.
do you have, huh?
So when are we? 9 o'clock?
Yeah.
No,
I
not.
don't want to be in this.
I think
The lines are-
here's the thing. The other issue.
We're on 22 and it's 39.
This K nearest neighbor algorithm, I'm going to do this next session. We're not going to do that all. But a little bit of massages. Okay. Let's finish up then. This is a preliminaries. This decision tree is based upon Bayesian theory. Bayesian is the name of a person. Bayesian theory is based upon conditional probability. You know all the conditional probabilities, right?
Sure.
So given probability Px, conditional probability will be in this way. For example, let's say case x2 occurs. Assume case x2 occurs. Then based upon that occurrence, what is the probability of the occurrence of x1? There's a probabilities. Okay. The example is this. I'll come to school tomorrow, given the condition of the weather, windy weather. If the weather is windy tomorrow, then I will come. What is the probability of my attendance tomorrow's class? That is the conditional probabilities. Okay. Given the weather windy, my class attendance the probability of that for tomorrow. That's written in this way. Probability P of attendance for tomorrow's class given the windy weather. There's a conditional probability. What's the probability of my class attendance? It's conditional based upon the windy. Okay. If we have two cases occur, x1 or x2, then joint probability is the probability of x1 comma and x2. We don't need to consider this, but Bayesian theory is this. Based upon this probability, conditional probabilities, for example, given windy weather, the probability of my class attendance is written in this way. How can we calculate it? We can calculate it in this way. If we know the probability of windy, there's some probability of windy, right?
Yeah,
So we know that.
8 mile an hour.
Mm-hmm. And then also we know the probability of class attendance. My habit is, for example, 90% class attendance, or 45% of class attendance. So we have that, right? Yes. And also, once I attend the class, then what is the probability of the weather? According to my experiments, my real data. As far as I attend, then weather is good or weather is bad or whatever that, okay? That probabilities. So we multiply P probability of X given C times probability of C over probability of X. That is called, this is a prior, which means that is given. We know that my habit of class attendance. And also we have evidence, the weather evidence. We all have this, right? This is a likelihood. Likelihood means it's not really confirmed. It's not really always true, but likely. There's a likelihood, right? Then, thing is this. This is a prior, so we already know this. My class attendance habit, I know, right? Evidence, we have evidence about the weather. So likelihood, as far as we have likelihood, if we have this likelihood, then we can calculate. Oh, by the way, after the situation, I can say this is a posterior, right? Post means after. After that situation, I can say, oh, by the way, that is the case. That is the case of probabilities, which is P of my attendance based upon the weather. Actually, I do not attend the class based upon weather, but we can compute, okay, based upon the likelihood. That is possible in this example. Let's say we have a robot. Robot has a measurement. For example, proximity sensor, or it has a motion sensor, So this robot can view the door. Then we want to compute what is the probability of the door open given some measurements. Okay. So what we want is that here, given the measurements, what is the possibility, what is the probability of the door open? That is what I want to. Okay. This is exactly the usual cases robots can make decision based upon, right? Because the robots, this is not known, but we can compute based upon known. Some of these are known. For example, this is what we want. This is diagnostic, right here, left hand side. This is causal, which means what is sensed if door is open. If door is open, for example, in this case, according to the experiments, if door is open, then door opens that way, push door, then proximity, the distance between this and that will increase, right? Or whatever. So we know the probabilities, right? If the door open, then proximity sensor gives us, for example, 5 feet. What is the possibility of the 5 feet from this sensor? Maybe 100% or 90%, 95%. There's the probabilities that we can have, right? Probability of a door open. This is also known, right? And what is the probability of that sensor? There's something that we do not know, but we can calculate. Probability of Z, here, some sensor, can be computed by adding those two. This can be, probability of Z is the probability of Z given open times probability of open. So in the case of a door open, the probability of Z. In the case of door close, the probability of Z. Then probability of Z covers all the cases, right? Probability of Z covers, there are only two situations, door open or door close. By considering those two cases, we can compute the probability of that measurement of that sensor. This sensor reacts based upon two cases only, door open or door close. In the case of door open, the probability of Z, that is this. In the same way, we can make probability of Z given not open. If we know this, then we know that. Therefore, we can compute this. All together, it will be like this. For example, if a door opens, the probability of sensing is 60%. If door closed, the probability of sensing is 30%. And probability of door open or door close is half and half, so 50%. So question here is that what is the probability of door open when the robot measure the sensor Z? Given sensor Z, the probability of door open. It can be computed in this way, right? Probability of open given Z is probability Z over open times probability of open over divided by probability of Z. This whole thing is probability of Z. This means probability of Z. So plug this 0.6, 0.3, 0.5 into here, then we have this. Okay. What is this? This is a posterior. Posterior. See here, posterior? So what happens here is that this is a likelihood. This is a prior. This is well known. By the way, that is well known, right? Probability of door open or door close is 50-50. This is well known, which is called the priori. And this is a probability of, this is evidence. Okay. This example may not give you good motivation. Maybe. Therefore, I can bring another visual motivation. So after I do, then we will stop. Okay. Let's assume we have objects, bubbles, red bubble and green bubbles, and they are all well structured. Okay. So we can calculate the prior probability of green, prior probability for red, which means prior probability for green. We count number of green objects over total numbers. How many totals? We have 20 red objects and 40 green objects. So total 60, right? So 60. What is the prior probability for green? So 40 over 60. What is the prior probability for red? 20 over 60. What does that mean? It means if you have any objects that the probability of that object belongs to green is this probability, like 66%. So 66% possibility that any given object can belong to green class. If you have any objects, then what is the possibility of that object belongs to red class? That is this probability, right? 33%. 33% of any given object that can be belonging into red class, or 67% of any given objects can belong to green objects. That's what it is. That is called the prior. Alright? So let's assume you have an object. Here, white objects. What is the probability? Which means, given white objects, does it belong to green or red? Why?
More green.
There's more green, right?
Yeah.
That's true. So far, that is true. assuming that all objects are well clustered, right? They are well clustered. So that's green. Membership is green. Is it reasonable to assume that more green objects in the vicinity of X and more likely that a new case belong to that particular color? But in order to use the conditional probabilities, this is Bayesian. Let's assume that we consider some condition, X. If we consider this, see here, measure the likelihood that objects belongs to class, which means probability of X, this is X. Okay. X given green. If this is the condition, okay, X, then the probability of the green, which is in this X likelihood, is only 2 out of 40. See, we have 40 green objects, but out of 4, we have only 2 green bubbles within that X boundaries. So that is the probability of X given green. That's this. What about probability of X given red? We have 20 red objects. Out of 20, we have 4 objects belonging to this X. So probability of X given red is 4 over 20. So posterior probability of X being a class, which is we already considered, which is prior probability of X times likelihood of X given class. So it is computed. What is the posterior probability of X being green is, see here, prior probability of class, of that class. Green, that is 40 out of 40 over 60. If it is red, that is 20 out of 60. And then it says likelihood of X being class. That is this, likelihood. 2 over 40 and 4 over 20. Times 2 over 40. Here in this case, 5 over 20. So what is this? We cancel 40 and 40, then this is 2 over 60. We cancel 20 and 20, so this is 5 over 60. So given this condition, what is the color of this object? Red, because this is likely. This is a posterior higher value. This is a low value.
So even though there are more greens, there are actually more reds.
If we have this likelihood.
So Trump wins.
Yeah, somehow. That is a Bayesian. Conditional probabilities. What it is that, remember that decision tree? We consider this, like age is greater than 30 or less than whatever the number, right? So if we have that condition, then we have different classifications. This is the theory behind the classification. All right? So this is it for today. So today we did decision tree construction and usage plus theory behind the decision tree. And next week we will do K-nearest neighborhood-based classification. Okay? So still classification.
Can we do something a little bit more hands-on, like a little, like using a program like Owlery? Like, just because I was not familiar with that syntax at all. I mean, this, alright, interactive, but...
Thing is, when I bring hands-on, then you said, oh, that's too much. When I don't bring hands-on, then you said, oh, we need hands-on. So there's no way that we can do.
We gotta find a balance here, because this is like...
Yeah, I'll try. Yeah, it's not a problem. I can bring hands-on all the time.